Okay, we got a fair number of people here, so we'll look to get started here. So, good afternoon and welcome to our Let's Talk Energy event, where today's subject is power system retrofits. Let's explore how to avoid obsolescence and reduce facility risk. Please note, this event is being recorded and will be available online to all. My name is Chris Dorlairs, and I will be your host today, along with our co-host, John Shaw. I've been working in the electrical field for just under 25 years, and I currently support the Retrofit business teams using my background as an electrical engineer. Outside of work, I enjoy fishing and skiing with my family. I am joined today by our subject matter experts, Chris McMullen, Michelle Godin, and Eric Wilms. We will be hosting a second event later this year in French, in which Michelle will be leading. I will pass it over to Chris for introductions.
Well, good afternoon. Again, my name is Chris McMullen. I've got 35 years experience in the trade under repair, maintenance, and supporting our customer base for emergency and prime power systems. Outside of work, I enjoy spending time in my shop tinkering and restoring rusty old things and fishing when I can get out to it. Back to you, Chris.
Thank you, Chris. Eric, over to you.
Thank you, Chris. Good afternoon, everyone. My name is Eric Willems. I've been an electrical engineer for 42 years, and 12 years ago, I joined the Toromont Engineering Department. My current role is a retrofit specialist for the Power Systems Group, with a focus on improving the reliability of existing generators, fuel systems, exhaust and emission control systems, and switchgear. When I'm not working on retrofit designs, I enjoy coaching minor sports and participating in long-distance running events. I'm currently training for the Toronto Waterfront Marathon, which is held in October. Over to you, Chris.
Thank you, Eric. Michelle, over to you.
Good afternoon. My name is Michel Gandon, Major Account Manager and Retrofit Specialist for Quebec and the Maritimes provinces. My background, electrodynamic technicians, with 35 years of experience on generator application and product support with Hewitt and Toromont CAT. I enjoy traveling, but on what? My Harley Davidson motorcycle. So if you have a chance to see me, don't forget to say me hello. Back to you, Chris.
Thank you so much, Michelle. So let's get started. Chris, I guess the first topic we should define is, what is retrofit?
Well, the general definition of retrofit is an act of adding a component or accessory to something that did not have it when it was manufactured. We have some pictures here to help expand on this statement, well, because I like pictures. Back to you, Chris, for the pictures.
Interesting, Chris. So, Chris, can you outline some of the considerations or the why for performing retrofits?
Absolutely. Aged equipment, new features would be the first slide we have here. Usually 10 years old and over, we want to address our electronics as shown in the image, outdated software and other potential. As a service tech on several occasions called out to repair systems that found to be obsolete, it's not a good conversation you want to have with your customer at time of failure. As a retrofit rep, I have some customers tell me that they've got spare parts or that they can get them from eBay, sorry. Note to the group, PLC components age whether they're powered up or not. Capacitors inside those components are subject to time. An example of new features here, increased in system performance or requirements or programming code updates to suit changing needs to the facility. Power system importance. What does it mean to you? There are not many applications where it's okay to have your emergency backup down for any length of time. As stated here, is your system mission critical, or can you sustain a long downtime in the magnitude of weeks or months? It's ultimately up to you and your service provider to ensure your system remains in a state where it can be supported. Time is not your friend when it comes to emergency power systems because they hardly ever run. Engine shows almost no wear or aging, but the electronics and cooling system are in operation 24/7. Back to you, Chris.
Hey, Chris, before we hop into that next question there, we got a question in the chat. Someone's asking, what is a mission critical system?
Yeah, sure, thanks. John, mission critical is a term used to describe the level of importance to your power system's availability and what it means to your organization to function without significant consequences. For example, loss of life or high financial impact or even major equipment damage.
Thanks, Chris. That was actually a two-part question. What is a mission critical system, which you answered, and are there any other considerations?
Well, and again, mission critical, we put that term out there to really classify how important it is to your facility. If you don't have backup power for your lights, stairwells, that kind of thing, people can't exit the building safely. I'd like to attach a mission critical statement to that. So very important based on your facility requirements. Another one here is risk and reliability management. Now that we've established the importance of your system, how reliable is it and what risk does a failure present to your operation? A site assessment can help you navigate the risks ahead, how quickly you need to act on a retrofit. Although the ability to support varies with product, it's safe to say that 10 years for your control system should have a service life audit to know where you stand in terms of obsolescence or ability to support so you can continually monitor your risks and reliability going forward. Be aware that security and obsolescence challenges change frequently, so doing annual inspections is very important. Now, speaking of security, as shown, cybersecurity and remote monitoring is an ever-increasing concern. With technical advancement comes cyber risk. Old systems are no longer an island when it comes to remote monitoring and security. IT departments have new requirements for building automation systems and the way your power system should be integrated into those systems. Or you have security concerns of being hacked through aged Modbus or SCADA systems currently installed. Back to you, Chris.
Thank you, Chris. So, Eric, can you describe the panel audit process? How would one go about that?
Okay, sure, Chris, I can do that. A retrofit specialist will contact you and schedule a meeting to discuss a site visit. We would begin with a virtual meeting to learn the general description of your facility and to answer any technical questions before traveling to site.
So, what can be prepared ahead of the audit?
Well, Chris, a single line diagram and other site drawings are very useful. Electrical single line drawing provides important information on the size of the generator, the voltages of the equipment, and the overall scope of the project. Another important drawing is a layout of the facility. This drawing will allow us to understand the space restrictions and to determine where new equipment can be located. Site photos and site contacts will provide detailed information. It is very useful to have photos of the nameplate data and the serial numbers of the key power system components, including the generators, the fuel systems, exhaust systems, the switchgear, protective relaying, and of course the PLC controls. The names and the email addresses of the key maintenance persons and operations contacts is important for arranging the site visit and meeting times and places. New features are also an important consideration. It is also a good idea at this time to consult with the members of the site operating staff to determine if any new features are needed to improve the functionality or the efficiency of the generator. Also, any nasty bugs inherent in the system like nuisance alarms, those should be mentioned at this time. Together with your internal management team, you should prepare questions relating to improved life cycle costs or any new plans that you have to expand the operation. Back to you, Chris.
Thanks,
Hey,
Eric.
Eric, are there any methods for performing these audits remotely?
Sure. We can make use of a video chat program such as FaceTime or Zoom. A qualified person on site can use a cell phone and walk around your facility, taking a video of the equipment. Our retrofit specialist can direct the person to navigate the camera and remotely view the equipment. Back to you, Chris.
Thanks, Eric. Nasty bugs, we got to get rid of them. So how would one request an audit?
Well, Chris, from a Tormont perspective, the easiest would be to call or email any one of the presenters in today's session. You can access our online link by entering the internet search words Tormont Retrofit Audit. Or the simplest way is to contact a local Tormont branch and request to speak with a retrofit specialist. Tormont has an extensive retrofit team, from sales to estimation. We have dedicated retrofit design engineers, PLC programming, field technicians, and field engineers. And the most important thing to remember is that these audits are free.
Thanks, Eric. So earlier, we learned that retrofits help mitigate risk and improve reliability. Chris, can you describe the types of retrofits one might come across and the considerations you should review?
Yeah, of course. First one we have is switchgear and ATS upgrades. We may want to change the way our control operates with ongoing changes to the facility or application. Open transition between generator and utility was standard back in the day, but today's requirements require the benefit from closed transition. Testing becomes seamless. Power outages can catch us off guard, but retransfer back is seamless and predictable on how the facility will behave. We may now want to parallel our generators for their redundancy or increased capacity. We now have the means to operate our generators for global adjustment or to run our units in storm avoidance mode. Breaker upgrades, for example, another example we have is breaker upgrades using old enclosures and bus bars, electrically operated, or advancement in fault monitoring at the breaker. We could tie this topic to new updated protective relays with up-to-date coordination studies, maybe because the facility changes in the facility or expansion. One example of this is a substation with updated breakers for use with the new generator for closed transition. Breaker speed is critical, and the older breakers just weren't up to the task. Tap box upgrades. Tap box or connection boxes are a great addition to a system with hard to access connection points in the facility. Either load testing the unit you have or potential connection of a roll-up generator for support while your unit is under repair. Often while utility breaker maintenance is done, a part of the facility can be powered via the connection box. We bid on a project not that long ago where a tap box provided load share interconnect control between the roll-up generator and the existing generators. Generator controller and remote monitoring upgrades. Onboard generator controllers are typically modular based. Not often we can change out the failed part, but must change out the entire controller. This now affects everything wired to the controller. Duplicate sensors or switches on these engines can now be upgraded to watchdog or active type sensors. Logic in the control negates the need for a switch and a sender to monitor the same condition. An example of this is a customer's insurance for uptime and remote monitoring. Control and software upgrades. PLC and HMI obsolescence, like your phone or laptop, may have the shortest life cycles in terms of software and hardware support. One example we have is the ability or availability, but programming software runs off of Windows XP, and we no longer use Windows XP on our computers with the advancement of operating software and security upgrades. This becomes very difficult to support that product. SCR and GA upgrades. Exhaust scrubbers, or SCR, selective catalytic reduction, can be used if customer wants to run their generators for non-emergency application like global adjustment. Global adjustment is a cost savings program in Ontario and would be a whole discussion in itself. So please feel free to reach out if you'd like to learn more about that. One example is we have a customer who had buildings go up around them, and all of a sudden complaints started rolling in of smell and noise from the existing generators. SCRs were the solution for this particular example. Mechanical upgrades as another item we have. Although we have a picture of a radiator, this retrofit can be as much about a mechanical aspect than electrical and control. Premature failure of block heaters, cooling systems that may not have been kept up to spec for corrosion inhibitors over time and may not be able to repair. One example is an ag customer we had with overheating issues with the current OEM system. We offered a heavy-duty cooling package with dust and dirt traps to allow the customer to clean out the dust buildup within the fins of the rad. Alternator upgrades. Alternator upgrades are rare in the standby application, but with prime power in harsh environment offers challenges. Alternator upgrades to form wound versus roundum wound will live longer in a salt-laden atmosphere near the East Coast or aggregate applications with abrasive dust entrained in the air being drawn through the alternator for cooling. Often with alternator failures, we can help out with a failure analysis, and recommendations are made for this type of upgrade. So I'll hand it back to you, Chris.
Thank you so much, Chris. So I'll just pause momentarily here to see, is there any questions, John?
Not at this time, Chris.
Okay, and then for the audience here, I do see a couple of questions coming in. Just you can direct them to everyone, so John Shaw will be picking them up. And some of the questions that I've seen here will reach out to you at the end of this presentation. So we talked about the types of retrofits. Eric, can you provide an example of a recent retrofit?
Sure, Chris. This slide that we have in front of us has two photos of a site that was commissioned last December. The photo on the left was taken during the audit prior to the retrofit project. The photo on the right is the system as it was commissioned in December. The system was taken offline on November 15th, and it was returned back to service on December 15th. This is a financial data center. The system has two 1,500 kilowatt diesel generators that are operated in parallel to support the data center load. The facility has been in service for over 40 years and has had several expansions. Initially, the request was for an audit. Now, the request for an audit was driven by an intermittent nuisance alarm on the two generator controllers. The photo on the left shows the paralleling switchgear prior to the retrofit. I direct your attention to the closed door with the 5 meters on the top. The generator controller is a large square panel in the center of the door. To avoid nuisance alarms ringing into the main control room, the alarm conditions were not reset, and the red LED alarm lights on the generator control panels were left on all the time. A full audit was performed. The audit identified the fact that in addition to the generator controllers, several synchronizing and protective relay components were obsolete. This system was installed in the year 2000 and all of the control hardware was 21 years old. If you look at the photo on the left, the first open door contains the PLC and the HMI. The PLC rack can be seen on the top of the backplane. This PLC was of an age that the OEM no longer has spare parts. The second panel with an open door contains the synchronizing controls and the protective relaying for generator 1. The large control device in the center is a Woodward synchronizing controller. Many of the components inside this panel are obsolete and do not have direct replacements with matching footprint and terminal block arrangements. Every component in this panel is critical for the parallel operation. If any one of these components fail, it will take time to redesign and rewire the back panel to install the replacement device. Because these electronic components are 21 years old, the risk of failure is high and the downtime would be significant. Over to you, Chris.
Great, Eric. Thanks so much. So what would need to be considered when performing a retrofit like this?
Well, Chris, the first consideration should be to improve the overall reliability of the system. The risk of downtime will provide incentive for the senior managers to approve the project in a timely manner. The operations manager and the retrofit specialist must clearly articulate the risk of downtime, the risk of loss of business revenue, and in some applications, the possible loss of life. After the project is approved, the design team must look at all items relating to safety. Two key safety codes to be reviewed are the Electrical Safety Code and the CSA Fuel Safety Code for the diesel fuel. At this site, the fuel system was recently inspected by a TSSA OBT1, Oil Burner Technician 1, and also the fuel supplier of the diesel fuel. So no changes were required to the fuel system. With regard to the Electrical Safety Code, the plans were reviewed by the Electrical Safety Authority in the design phase. The local ESA inspector was engaged at the beginning of the project. This inspector visited the site several times, and they provided the final approval to energize the system. Other items to consider are the opportunity to perform engineering from scratch. We have the advantage of an experienced operation and maintenance team on site who can provide feedback and recommendations for design changes. As a part of the retrofit project, we have the ability to add new features and resolve historical operating concerns. Back to you, Chris.
Hey, Chris, here's a question that's actually probably good for Eric. Are you able to maintain site operation during a retrofit?
Thanks, John. Yeah, we can make use of a rental generator. If there's a maintenance outage scheduled in the near future, we can use that to complete the retrofit project within the available maintenance window. Temporary transfer switches and quick connect boxes can be used to reduce the installation time. During the site audit, we will review what is needed to connect a rental generator to the existing system. Back to you, Chris.
Thanks, Eric. So we have looked at one type of retrofit example, switchgear retrofits. But what about some very common retrofits, such as generator controller retrofits, where there may be cost sensitivities? Chris, can you walk us through a recent generator controller example?
Sure, Chris. As you can see here, we have a very old and obsolete generator controller still in operation, no issues, but ready for retrofit. The consideration before even getting started working with the customer is looking through and how I'm going to integrate the new control into the facility. New features to consider when looking at how much to spend on a basic system or advanced system. From here, the type of controller can be selected. In this case, it was a lower cost alternative and was able to be used. In this project, you can see here where we were able to reuse the old panel box and some of the old wiring. when providing retrofit solutions, I always try and consider how the new system will be supported through our field service team for the long term, keeping some items like OEM harnesses where feasible to help reduce the costs. As you can see here in the third image, we used a cost-effective, CAT-approved and branded controller option that met the needs for this application. This controller can easily be supported, updated drawings and support documents come standard as part of the retrofit project. Back to you, Chris.
Thank you, Chris. So, John, are there any other questions? We're going to open it up for a discussion. You receiving anything on your end for questions for the team here?
We got a couple, Chris. So first one, throw it to you, and then you can pass it on if you need to. From a capital planning standpoint, after how many years should a diesel generator in a hospital be replaced, even if it's been running without issues? How long will spare parts for a particular model be available?
I can.
You want to answer that?
Yeah, I think I can take that one. So it really does depend on the type of generator you're using. I would feel comfortable in speaking about the Caterpillar generator, is we can still obtain parts for generators we have in service all the way back into the 60s. So for hospital mission critical type application, often again, standby generators hardly get any runtime in. So, you know, it'd be important to do annual inspections and keep in mind parts availability, but really where we do see obsolescence issues is in the control side of the equation, whether it be breakers or physical controls from the generator itself.
Yeah, electronics go obsolete after like 10, 15 years, right, Chris?
Yeah, the iron is quite timeless. And I mean, if you're gonna, you know, bust a major component like a crankshaft or punch a hole through the block, of course, that's quite severe. You may want to look at upgrading at that point, but I don't know of many circumstances where upgrading, at least in the Caterpillar world, upgrading a unit that's any older than 30 years old is warranted. And again, these numbers, I'm kind of shooting from the hip a little bit, but in most cases, as from a service technician, I could get parts readily available for anything that was 30 years or newer. Does that help out?
Thanks, Chris.
Yeah. Next question. So one of our regulars on the Let's Talk Energy Sheridan has been talking about the concept of microgrids, which incorporates traditional power sources with newer, greener energy, such as battery energy storage systems and solar. Can you retrofit an older, less efficient system to integrate newer renewable technologies?
Can I take that one, Chris?
Sure, absolutely.
Okay. So there's definitely methods of improving the efficiency of the generator or the use of fuel. We're slowly moving into a hydrogen-fueled world. The source of hydrogen is not yet clear, but definitely Caterpillar has made a number of changes to their equipment to be able to accept a percentage of hydrogen, say in 10% or 20%. We can also add a biofuel kit to a diesel generator. Many hospitals have them where they're operating on diesel, and then they slowly admit some natural gas in. And in microgrids, we have the ability to, with our switchgear and controls, the Caterpillar controller is quite good at accepting additional I/O to provide the addition of solar PV or battery to our power system.
Thanks, Eric. Yeah, and that's fantastic. And just to add to that, you know, the controls can be retrofitted to interface and share load with newer microgrid systems. We can place microgrid controllers in, or hybrid management systems in which we can base load to, and the retrofit piece would do the upgrade to the existing power plant to allow that to happen. So answer that, very much an old system can be integrated with a new microgrid battery energy storage system. So that is very possible. Thanks again. John, any other questions? I see there's a few more coming in.
Yeah, so
Do you mind if I just interrupt on that last topic?
Sure.
Sorry.
Absolutely.
So just one note is, whatever controller we select for your facility, it doesn't matter what color the iron is. Most of our controls also come with all new updated sensors or switches. So we can custom build a harness to suit the new control and new senders, whether it be a old Detroit or a Cummins or Mitsubishi, any of those we've done upgrades on in the past. So although I commented earlier on lifespan of an engine, I could speak more comfortably on the CAT product. Anyway, just wanted to add that point.
Thanks, Chris.
I've got one more question here in front of me. Would it be possible for a generator to be connected in closed transition mode and peak shaving? How can we achieve this target without going above the 100 millisecond limit?
So I can jump on that. The first thing we need to do when we're looking at the possibility of closed transition or peak shaving is the connection agreement assessment we need through Hydro. So Hydro is the first one to say, yep, you can go ahead and close transition to the grid, or no, you can't, or it must remain in the 100 millisecond aspect, or yes, you can base load your unit to the utility and remain that way as long as you want. And again, adding to that is if we are going to set our unit up, excuse me, for peak shaving or global adjustment, now the Ministry of Environment gets involved and we have to potentially add scrubbers or SCR to the genset to clean up the emissions so that we can run for non-emergency use. How's that?
Thank you, Chris. And actually, just leveraging something you said earlier, these are great topics, and one of them actually we do have lunch and learns that we do a deep dive into this very subject. So please inquire with our team, and we can establish some lunch and learns go in much more detail on the topic.
We frequently do retrofit systems that were used purely for standby or emergency, and then are used for time of use or demand response. That is a pretty common retrofit. Absolutely.
John, any other questions?
That's all I'm seeing, Chris.
All right, I've got a few here. The one customer has asked, will stating a project being mission critical speed up the project?
That's a good question. And again, I'll jump in here. And again, in terms of putting the project together, really is largely due to the complexity of the project. Being mission critical obviously does, create some urgency behind it, but retrofits were never designed to substitute for a unit down. And so it's important to realize that retrofit should be taken in a proactive approach as opposed to a reactive approach. You want to plan ahead, you want to plan out your retrofit, and you want to do your retrofit before it leaves you in a down situation that can't be supported.
Yeah, if you wanted to, like if you had a mission critical system, you definitely should have a tap box that gives you the capability of connecting an alternate generator, like a mobile generator at any time. And I'm always surprised how many places that are mission critical and don't have a tap box. I recently visited one this week, and you have to spend at least 12 hours connecting to an existing bus. Had they have ran the tap box, it'd have been, an hour to connect up a rental generator. So if it's mission critical, you should plan ahead for downtime. That's all I have to say.
Thanks, Eric. And actually, this is great because following the mission critical conversation, I think, Chris, you've kind of answered this. When do we know it's a repair or service versus a retrofit? And I think you've kind of touched on that. I'll let you maybe expand on that a little bit.
A lot of times as a service technician, you're going in and you're doing what you can to get them back online. And, you know, it might involve jumping out a couple of points, or it might be getting in a spare used replacement. But certainly, once you've recognized that you've got an obsolete system, you really need to do some planning and budgeting. You know, we've got some customers that are budgeting a year out or 2 years out, but the key point is they've got a plan.
That's perfect. Thank you, Chris. And then how would an end user know if their genset is due for a retrofit? Erica, I'll send that over. And if the genset has no problem and is operating fine, how would they know if they have to do a retrofit?
Well, I think it's a good idea for anyone with a system that's 10 years or older to have one of our retrofit specialists, that's one of those three, or even your product support sales rep, to have a look at the equipment. And it'd be nice if you could open up the control door safely with a licensed electrician and take a couple of photos of the protective relay, the synchronizing device, PLC mainframe controller. What else? Those are the three main items. If you took photos of those and sent them back to us, we'd be able to quickly tell you, because we work with these every day, quickly tell you which ones are, you know, still in production and which ones are obsolete. 10 years seems to be the length, but just remember, you may have bought a piece of equipment that was designed 5 years before you actually had it landed. So then that makes it 15 years old. So that's why you got to be careful. You may have just installed it and there still might be one or two pieces that are obsolete just because of the design phase. Chris, do you got anything to say about that?
Well, I was just going to say, sometimes that's a hard pill to swallow, because, you know, you just bought this piece of equipment and you just got it in, and then the service tech comes in and goes, oh, by the way, that PLC you've got in that cabinet it's at its end of life, or there's a service letter out. And at that point, there's typically a couple of years of support behind that with product that might be left on a shelf somewhere. But you certainly don't want to get to a point in the controller's lifespan that is completely obsolete and no support, no hardware or even the software to communicate with it is where we really run into problems. And again, going to eBay, it's a crapshoot whether you're going to be buying a controller that's going to give you a month's worth of service or a couple of years extension from that obsolescence. So you're kind of playing with fire at that point.
The one thing you should know is most of the equipment that are inside a control panel are generic pieces of equipment. It's not like they're exotic. And so there is quite a bit of information on obsolescence of these devices. So that's an important thing to know. Like, it'll be quick to find out. If you took photos of the equipment and gave it to your product support sales rep or a retrofit rep, we could tell you quickly whether it's obsolete or not.
Thanks, Eric. And I got a few more here. There's a thing here, can non-CAT or CAT products be retrofitted? Is a question from the audience.
Yeah, absolutely. Like I was saying, whether even a CAT controller, I can put a CAT controller on a Cummins unit or a Detroit unit. I can put a non-CAT controller on a CAT unit. It really is, most of the controller suppliers nowadays have generically built their controllers to marry up to a certain type of sensor or speak on a certain comms, and we can integrate most units Cummins comes to mind with their power command controller is a fully integrated controller. And they've done a great job making this particular one proprietary. It's very difficult to put a non-Cummins unit into that because the governor and voltage regulator are integrated in with the controller. So that's the only one that we've kind of run on up to some roadblocks on, but you know, even the older Cummins units that didn't have that type of integration was no problem in upgrading those units. And I'll add too that the new units where we've come with Ethernet communications, Modbus, remote monitoring, remote dialers. It's incredible the optics that from a monitoring standpoint that as a customer you can have on your generator. Lots of times, you know, the power goes out, we didn't realize the breaker was tripped, or we didn't realize the unit wasn't put back in auto, that kind of thing, just because of the inability for some of the older systems to provide that remote communication for monitoring purposes.
Perfect. Thanks, Chris. This is the last one here. Say a consultant is just evaluating or supporting a client up in the far north and looking at adding capacity, and would like to know, you know, what type of integration details and information from site is needed to retrofit an additional generator to look at the controls. Can you guys describe maybe quickly what they might need to consider and what kind of information they should obtain?
Well, single line drawings and serial number of the engine and the alternator. That would be very handy because again, there's different iron, some people put different alternators on different manufacturers of engines. So both serial numbers is a big deal. And then photos of devices, particularly wiring. The terminal block on the bottom of a controller is pretty handy to determine if it's a non-CAD item, to determine the age of the device. Is that what you're asking, Chris? Is that what they're asking?
Yep. Thank you.
I think single lines is really important. It gives us a kind of a 30,000 view look at how we're going to integrate that unit for capacity, what type of paralleling devices are connected to it, what type of control. That would help us select what we need to marry up to the existing system. And even a sequence of operation is huge in terms of how the system's supposed to behave and operate. You know, what generators come on, is it load sense, load demand? Do we need any type of load rejection downstream, shedding of load, that kind of thing. So, you know, as we move forward, we can coach a lot of the customers for the information that we're looking for, and we can kind of unearth a lot of the information we need to make a good informed decision moving forward.
One other piece of information I want to pipe in here, it's one I use all the time, is I take a picture of the installing contractor's name or the engineering design company's name, because it's a very small world, especially if you go to remote communities. There's probably 30 engineering firms and 30 constructors, and we, over the years that all of us have worked, we know one or two people in each of those places. Maybe they've retired, but we'll definitely get somebody who'll say, hey, I remember installing that, and I can give you some insight, right? It's a small world of people that do this work. So getting a name would be handy.
Absolutely. And I'll actually add, Eric, just kind of continuing on one of the questions that John asked, using technology. So in the question from the audience here, you know, they're up north. How do I, you know, typically it's a plane ride, but if you want to get some preliminary information up front, technology is great. We have the ability now to video stream in. So if someone's on site, we can, you know, video stream into the panel, have a qualified technician open the panel, and we can then remotely get the information we need to have fruitful conversations. So I know, Eric, you answered that earlier, so just a reminder to the audience, there's lots of different ways we can use technologies today to help you start the conversation of what the next steps are. John, is there any other questions from your end?
From a retrofit, do you provide warranty or even extended warranty on that?
Let Chris Dorler answer that one.
Okay, so that's specific to Toromont. So I mean, the Toromont retrofit services, yes, there's a warranty that is provided with the retrofit part of the project.
And just to add to that, it's important when we look at retrofits that we just don't retrofit, or we just don't look at that one small piece. We have to address a retrofit as a system. And so, you know, you've put in a brand new controller over here, you've paid for the engineering, you've paid for the diagrams, you've paid for the install, but then you've got several pieces over here that are still aged, but maybe not retrofitted out. So we have to be careful about just retrofitting the small picture type stuff and not looking at the overall picture. And again, with some of our previous examples, we try and use what we can, because we don't want to invent the wheel every time we do a retrofit and strip everything out from scratch. But we do a pretty good job at looking at all of the pieces of the puzzle and addressing the obsolescence, and at least giving the customer the option of saying, yeah, I want that changed out, or no, I'll take my chances for now on that. And really it is, you know, anything mechanical or electrical, we're going to guarantee at some point in that thing's life it's going to fail. And it's just a matter of risk management. As long as we can still support that piece that can fail, you know, you're good to go. I mean, it's retrofit isn't there to completely 100% guarantee you that you're never going to have another problem for 10 years plus. So just wanted to add that point.
And I want to pipe in there. You mentioned in your presentation, Chris, the fact that cooling systems are on all the time. So because the block heater's on, it's generating heat circulating around the rad. So then you also have the coolant liquid itself deteriorating, or the pump slowly leaking because it's just age, right? It's heating and cooling. So when you're doing a retrofit and you think you're only doing the controller, or you're only doing a breaker, you should look at things that are in that coolant loop because of corrosion and heat cycling. Coolant pumps fail a lot, right?
Yeah. Hopefully your service provider has done a good job at making you aware of that. But in some cases where we do have a 20 or 25-year-old unit, the radiator built back in those days, the manufacturer didn't build the rad. The rad was built for the manufacturer or the OEM, and they put that package together. So quite often when we do mechanical retrofits, we're retrofitting a third party or a non-OEM component in. We grab the engine heat rejection data and all the rest of the pump curves and that kind of thing, and we calculate what is required for a new radiator, if that was the case. But certainly over time, the cast iron attacks coolant nonstop. It doesn't stop degradation. We've seen aged radiators with solder bloom. And again, to try and repair a piece of Swiss cheese is very difficult. It's your best to just get a new rad core in, or potentially a new radiator altogether.
Perfect. Thank you, Chris. Well, with no further questions, this concludes our main event. We also want to let everybody know we'll be conducting, as mentioned throughout the session today, various lunch and learns on topics. So encourage, if you have a specific topic, please reach out to our panelists, and we can certainly set up a lunch and learn to do a deeper dive into specific subject areas that you would like to look at. And please feel free to give us feedback on today's presentation. And so with no further questions, we thank you all for attending, and stay tuned for our next Let's Talk Energy event.
Thanks for your time.
Thanks.
Thanks, everyone.
Thanks, John Shaw.